Hi, do you have a manuscript? 2 or many unpublished manuscripts? Do you want to learn how to self-publish on Amazon? Search no more. Just send me a DM on my WhatsApp. Let's get started right now. Hi, you're welcome back to my YouTube channel. This is like I always explain, this is a channel of this particular channel is about chemistry, because in the last topic, my last video, I told you that I will now have 2 different channels under this particular YouTube channel. One will be about lifestyle and any and everything according to how I'm inspired. Yeah, and then the other one will be my chemistry. My chemistry channel will always be there. Yeah, so this particular one is my chemistry. It is going to be about chemistry. And if you're yet to subscribe, I know many do view but you don't want to subscribe. If you want to subscribe, please, and not if you want to, please subscribe. Hit that subscription button you're staring at, and then the notification bell by the side, so that anytime I post any content, you'll be able to get it. And for my returning subscribers, I'm really so grateful. I love you guys. Thank you for your support. So today we are going to continue on the discussion of separation techniques. Yeah, so let's get started.
Over the horizon, over the horizon.
Hi, you're welcome back again. So after the last topic where we discussed some separation techniques, today we continue with another four. Filtration is the first one. Filtration technique. This is used to separate insoluble particles. Please, for those who are just joining, you can just go back to my last topic and my last video where I discussed separation techniques. I've already discussed the first 4, and today I'm discussing the next 4. So filtration, this is used to separate insoluble particles from liquids. Many of us know about filtration. We have filter, at least when I grew up seeing filter in my house. When you want to go and drink, you just go there and put it on, turn the knob, and when it fills, you now turn it off. I grew up seeing filter in my house, so we are familiar with what is by the name filtration. So it's used to separate insoluble particles from liquids. Most times in the lab, a filter paper is used. Though the one in our house in those days, candles were used. Candles were used to, not the normal candle we know about, filter candle. Yeah, but that's not what we're discussing today. Today we are discussing the one at the lab. So a porous filter paper is normally used. For example, if you want to separate chalk dust, a mixture of chalk dust and water, it's mostly for insoluble particles from water. A mixture of chalk, when you grind chalk and put in water, of course it will not dissolve. Now you still be seeing those chalk particles because they are insoluble in water. So this filtration method is the best way to separate such insoluble particles from water. So when you now pour that chalk mixture into a filter paper, the water will now pass through and be collected in any container you have there, while the insoluble chalk particle will still remain on the filter paper. In that way, you have separated both of them. Most times this is used in water purification plants and brewery. brewery industries. You know, brewery industries where they produce beer, you know, these alcoholic drinks. It's used for removing the solid particles from the liquid. So that's all about filtration. And this is diagrammatic representation of the filtration method of separating mixtures. Now, in this situation, like I talked about now, we are going to separate chalk suspension we are going to separate chalk particles from a mixture of chalk and particles and water. So this is the chalk suspension now. These are apparatus. We have set up the apparatus. We put the beaker that we use to collect the filtrate, which is the water. We set up an inverted funnel with the filter paper. This is the filter paper. This is the filter paper. This is an inverted funnel. And this is the glass rod through which we now pour the chalk mixture. This is the chalk mixture. We pour it through the glass rod through the filter paper in the inverted funnel. Now, the filter paper, the liquid, the water will collect. We pass through the filter paper and collect here in the beaker, while the chalk particle, the residue, will now remain in the filter paper because we cannot pass through that filter paper. So this is how we separate chalk particles, the suspension of chalk in water, chalk particles in water using the filtration process. This is the water that has been collected, the filtrate, and this is the chalk particles. Centrifugation. Centrifugation is the next one. Now, there's a machine called a centrifuge, which is normally used in this method. This centrifuge is a machine which can spin test tubes containing suspension ground at a very high speed, and at the end of it all, the heavy particles will now settle down at the bottom of the test tube, while the water is collected on top. There will be a demarcation between the heavy solid particles, which are at the bottom, and then the liquid will now be up, because of course heavy substances are heavier in density than water, so they will settle down, while the lighter density water will now be up. It's normally used for small materials and mostly used in hospitals, where the blood samples are centrifuged in order to separate the blood cells from the plasma. However, it's very, very important to note that when a test tube of materials is placed in a centrifuge, it's imperative that it must be counterbalanced. It's imperative that it must be counterbalanced by a similar test tube containing the same amount of water. I will say it again. When a test tube of some materials is placed into the centrifuge, it's imperative that a similar test tube containing the same amount of water must counterbalance it. So that is for the centrifugation, where it is used to separate heavy substances from heavier density substances from lighter density substances, heavier solid particles from water. So this is the diagrammatic representation of centrifugation, just like I told you now, where is a machine containing test tubes which contain heavy suspensions being spun around at high speed, where at the end there will be a separation of the clear liquid and the insoluble particles. Heavier particles will settle down. So this is the machine. This is centrifuge. This is the metal containing those test tubes. This is the test tube, and this is the metal. Like I said, this is the metal container, and this inside is the test tube. And this is the machine. This is how it spins. It spins round, at very high speed. At the end, each of these test tubes will look something like this. Okay, the heavy particles will now, heavy solid particles will now settle down, while the clear liquid will now be on top. So this is the result of each of these tests. Will have this result. So use it to separate this clear liquid from the insoluble solids. Water. Then the next one is the flotation. The flotation comes next. Most metallic ores are found in nature in low concentrations. In nature, they are found in low concentration. Now, these sulfides contain earthy materials, and for these metals to be extracted, they must be concentrated by separating them from the mixture. Now, they must be concentrated in order to separate them from the mixture. This is a process called flotation. It's called process called flotation, where you have to separate these metals from their ores. Now, first of all, the ore is finally, in order to achieve this, you grind that ore into a fine substance. It becomes fine, then it's mixed with air and water in order to form a foamy, frothy substance. Now, after that, the water-wetted rocks and earthy materials, the ones that have been wetted with water, will now settle down at the bottom, while the unwetted ones, those that are not yet wetted, they will now be carried up in suspension as the floaty foamy substance, where they are then skimmed off or filtered in. So in that case, you have got those water-wetted substance, and as you have separated them, the heavier substance from the mixture which has been skimmed off, you've not got those your metal ore that you are looking for. They have settled down at the bottom. So that is all about flotation. Then, last but not the least of the one we are going to discuss today is the evaporation to dryness. Evaporation to dryness. This is used to recover solute from solution. This is used to recover solute from solution. Here, the solvent is usually sacrificed in the process. Not the sacrifice where you carry a human being and go and sacrifice. No, it's not that. It's usually sacrificed in the process. This is how it goes. A water bath or sand bath is used to bring about a steady rate of evaporation. A water bath or sand bath can be used. The solute required is now left behind in the dish after everything has been vaporized, while the solvent is evaporated into the air, is vaporized into the air. It goes off into the air, it's sacrificed into the, whatever word you want to use. We just know that it has gone and it has left us the solute that we are looking for. However, this method cannot be used for all salts, because some salts destroy on evaporation. So it's only for salts that cannot be destroyed on evaporation. These are the salts that we can be used in this method, mostly potassium and sodium salts. It is used mainly in salt making industries. Yeah, like along the western coast of Africa, seawater is poured into trenches and then left, so that the heavy sun will now cause the evaporation of the water. After a long while, this is a long process. What will remain behind is the salt, which is got in large quantities. Diagrammatic representation of evaporation. So this is the tripod stand. This is the heat being supplied. This is the water bath, or you can use a sand bath, anyone that is available. water bath. Then this is the dish, the petri dish containing the salt solution. So when this water bath is heated, this is the steam. This is the steam escaping. Okay, this is the steam which being escaped. This is steam which hits this water, this salt solution. It's heated here. The steam hits the water solution. There's a paper wedge here, so that steam can escape. If not, this can cause explosion. So there's a paper wedge here, so that steam can escape. And then the ones that have to also do the work will still do the work. This is the salt solution. As this is being heated, the solution, the water, will now escape into the air. What will finally remain here after the water has finished escaping is the salt. The solid salt, the solute, which is the salt, will now remain here. So this is for the evaporation. So with this, we have come to the end of today's session. Please don't forget to subscribe, hit the notification bell, like, and comment. All these are appreciated by me. Next topic will not be on chemistry. It will be on that. My next topic in this chemistry will still be on, while the next channel, my next video will be on life, all about life. Till then, see you. Bye.